Welcome to this practice session for signals and systems. This video is prepared for helping students in practicing numerical examples.
Let us listen to the instructions now. This video contains 5 numerical examples. Write your own notes while watching the video. Pause as and when required. Take time to grab the concepts. Rework on examples for practice. This is very important. Let us go to problem number 1. Given a signal x of t, sketch x of 2t plus 3. As we can understand, there are two operations involved. One is shifting, shift by 3 units. Another is scaling by a factor of 2. Here a question comes, should we do shifting first, then scaling? Or should we do scaling first, then shifting? Or will we get the same result irrespective of the order? We will try in both the ways and see if we are getting the same answer or not. First, let us opt for shifting. The signal x of t has to be shifted by 3 units towards the left side. Thus 3.3 will move to 0, minus 1 will move to minus 4. That is what is drawn here. The signal is spreading between minus 4 to 0 now. Shape of the signal, amplitude of the signal remains the same. Now, this signal we have to scale by a factor of 2. That means compress the signal. Each and every time instance in this time axis should be divided by 2. So that this minus 4 will change to minus 2, minus 3 will change to minus 1.5. Correspondingly, all the points will change. The graph of such a signal will be like this. It is spreading between minus 2 to 0. This is the resulting signal x of 2t plus 3 if we opt for shifting first and scaling next. Now let us try reverse order. Let us start with x of t again, do scaling first, then go for shifting. Scaling x of t by a factor of 2 makes this point minus 1 by 2 and this has 3 by 2, that is 1.5. So the compressed signal will be like this. It is spreading between minus 0.5 to 1.5. This is x of 2t. Starting from x of t, we reach to x of 2t. Now, let us shift this resulting signal x of 2t into x of 2t plus 3 by shifting 3 units towards left. This minus 0.5 will reach to minus 3.5. 1.5 will reach to minus 1.5. This is the resulting signal. We can see that the final answer we obtained in this case and in the first case, they are different. The signal is spreading between minus 2 to 0. This is spreading between minus 3.5 to minus 1.5. We are not getting the same answer if the order was changed. We have already learned, as per precedence rule, the allowed operation is shifting first and scaling next. So this is the correct answer. If given a signal x of t and we are asked to plot x of 2t plus 3, this is the correct answer, not this one. Let us try a similar problem. Given x of t, sketch x of 2t minus 2. Here also multiple operations are involved. We will follow the order which we have learned, that is shifting first, then scaling. The given signal x of t has to be shifted 2 units towards right. That means this point will reach to 4, 0. This point will reach to 2, minus 2 will reach to 0. So the resulting signal will be like this. The signal is x of t minus 2. Now the shifted signal should be scaled by a factor 2. The time axis of the signal is to be divided by 2. This 4 will be 2, 3 will be 1.5, 1 will be 0.5, 0 will be 0 itself. So signal x of 2t minus 2 is spreading between 0 to 2. This is the answer. This is the correct answer as we have followed the order, shifting first and scaling next. In problem number 3, a signal x of t is given. We are asked to sketch x of 3 minus 2t. This can be viewed as x of minus 2t plus 3. There are 3 operations involved in this question. First one is shifting by 3 units. Second is scaling by 2. Then reflection. We will perform this operation in the following order. First shifting, second scaling, and at the last step we will do reflection. Starting with x of t, let us shift this to x of t plus 3. This is the resulting signal. This has to be compressed by a factor 2. The signal was spreading between minus 3 to minus 1. Now it is spreading between minus 1.5 to minus 0.5. This is x of 2t plus 3. In the last step, we need to reflect the signal. That is, we are going to take a mirror image of the signal with respect to the y-axis. This will be the reflected signal. Original signal was between minus 0.5 to minus 1.5. Now it is spreading between plus 0.5 to plus 1.5. This is x of minus 2t plus 3, which is x of 3 minus 2t itself. In the next problem, starting with the same signal x of t, let us plot x of 0.5t minus 2. Here there are 2 operations, shifting by 2 units, scaling by a factor 0.5. Let us shift first and then apply scaling. Here the scaling has elongation actually. The signal is spreading between 2 to 4. Now it will be spreading between 4 to 8. We get x of 0.5t minus 2. Problem number 4. Plot x of t equal to u of t minus r of t minus 1 plus r of t minus 2. We have already learned that u of t is unit step signal, r of t is unit ramp signal. This is 1 unit shift, here it is 2 unit shift. Let us plot this component signals u of t, r of t minus 1 and r of t minus 2. At each and every instant, we should see what is the amplitude of these three signals and perform this operation. We have to subtract r of t minus 1 from u of t, then add r of t minus 2 to that. The resulting signal will be x of t. Let us consider the interval 0 to 1. We can see that u of t is present between 0 to 1, r of t minus 1 is not present, r of t minus 2 also not present. So x of t equation becomes u of t minus 0 plus 0, that is u of t itself. We can draw this part of x of t. Now consider the interval 1 to 2, t equal to 1 to 2. U of t is equal to 1, r of t minus 1 is picking up, r of t minus 2 is not present. So this x of t equation becomes u of t minus r of t minus 1. At t equal to 1, u of t equal to 1, r of t minus 1 is just starting. So it is 1 minus 0, amplitude is 1 itself. At t equal to 2, u of t is 1, r of t minus 1 has picked up an amplitude of 1. So 1 minus 1, it becomes 0. In between this 1 and 0, the variation is linear, just as in the case of r of t minus 1. So we get the part of the signal x of t between t equal to 1 to 2. Now from 2 onwards, t equal to 2 onwards, u of t is present, r of t minus 1 is present, r of t minus 2 also present. So this entire operation as per this equation we have to do. U of t amplitude is 1, r of t minus 1 has already reached to an amplitude 1 and increasing, r of t minus 2 is just picking up. At this point, it is 1 minus 1 plus 0, it is 0. Assume a point t equal to 3. U of t is 1, r of t minus 1 has reached to an amplitude of 2. So 1 minus 2, that is minus 1, plus r of t minus 2 might have reached an amplitude of 1. So the entire operation is 1 minus 2 plus 1, which is again 0. This will be true for any instant of time you take further, so that this x of t remains 0. That completes the plotting of x of t. In problem number 5, a signal x of t is given. We are asked to plot r of t equal to d by dt of x of t. The signal r of t is the derivative of x of t. That means what is the rate of change associated with x of t will be the signal r of t. If we look at the signal x of t and try to find out what are the rate of changes associated, we can see that in the interval minus 3 to minus 2, the amplitude of x of t is constant. That means derivative is 0. R of t becomes 0 during that interval. Between 2 to 3 interval also, R of t will be 0. In this portion of x of t, that is from minus 1 to plus 1, minus 1 to plus 1, x of t remains constant, r of t will be 0 during that interval also. When there is a change happening in this interval, that is from minus 2 to minus 1, and in this interval from plus 1 to plus 2, the rate of change is positive, it is increasing, signal is increasing at a constant rate. So we have a positive constant rate of change during t equal to -2 to -1. Similarly, t equal to 1 to 2, we have a negative constant rate of change. To find out the value of rate of change, if you take delta y here, it is 1 unit. Delta x is again 1 unit. So the amplitude is 1. The slope is 1. Here it is a negative 1 as it is a decrement. Similarly, here it is positive 1. So if we try to plot r of t, this is how the signal will be. During -3 to -2, it is 0. From -1 to +1, it is again 0. From 2 to 3, it is 0, corresponding to these 3 constant parts. For this part, the rate of change is a positive constant. For this part, a negative rate of change is indicated. At this point, t equal to -3 and t equal to +3, there is an abrupt change happening in the signal x of t. From a small magnitude, it is reaching to high magnitude in a very short interval. Here, from a high magnitude, it falling down to a very small magnitude. So this rate of change has to be approximated by impulse function. A high amplitude in a short interval of time, high increment in the amplitude here. Similarly, a sudden decrement is approximated by a negative impulse signal. That completes plotting of r of t. Now with the same signal x of t, let us try to find out a signal p of t such that p of t equal to u of t minus 2 into x of t. Let us plot x of t and u of t minus 2, the component signals. Now we need to do instant-wise multiplication between these two signals to find out what is the signal p of t. As it is a product, p of t will be having a value only when both these component signals have value. We can say that till t equal to 2, u of t minus 2 is 0. So all these portions of x of t will get multiplied by 0 and will not be present in p of t. P of t will remain 0 till t equal to 2. From 2 to 3, x of t is present, u of t minus 2 also present. This amplitude is 1, so x of t will be getting multiplied by 1, that is x of t itself. For t greater than 3, x of t becomes 0, so the product becomes 0. The remaining part of x of t minus 2 will be multiplied by the zeros. P of t will be 0. So only during the interval 2 to 3, p of t will have some value which is nothing but x of t itself. The resulting signal will be like this. This completes the plot of p of t. That completes the discussion in this video. Thank you for watching.